Today, let's get a closed form formula for the present value of growing annuity. If I put $100 into a bank, initially growing at 10% every year for 10 years, how much is it worth in today's dollar with 5% interest rate? Let's draw the timeline first. The timeline composed of a line and those time index below the line. They are in total of 10 years. Because we don't want to type it all out, so we just used an arrow to represent that missing point. The first cash flow is 100, paid it at the end of the first year. The second cash flow is 110. It paid it at the end of the second year. Because it's growing at 10%, so it's 100 times 1 plus 10%, so we got 1.1. So it's 100 multiplied by 1.1 equals to 110. The third cash flow is calculated by using last cash flow, which is 110, multiplied by 1 plus 10%. Because it's growing at 10%, the answer would be 121. So if you instead using the initial cash flow, which is 100, then it's 100 multiplied by 1.1 to the power 2, which is also 121. So if you use this logic, if you want to find the cash flow for the 10th year, you notice that the $100 is increasing by 10% 9 times. So at the end of year 10, it would be 100 times 1.1 to the power of 9. The answer would be $235.79. To find the present value of this growing annuity, you should discount this cash flow individually back to time 0, and then add those present value up to get the total present value. As you can see here, because the $100 is paid at the end of year 1, it should be discounted with 5% for 1 year. So you divide 100 by 1.05 to the power of 1. The next cash flow is 110, paid at the end of the second year. Instead of 100, we should put 100 times 1.1 as the numerator of the present value. It is discounted at the 5% for 2 years. Therefore, we divide 110 by 1.05 to the power of 2. At the end of year 3, the cash flow is 121. We decided to use 100 times 1.1 to the power 2 as the numerator. Then we discount the cash flow for 3 years, which is divided by 1.05 to the power of 3. Notice that the 1.1 to the power of 0 is just 1, right? Focus on the numerator. It is 100 multiplied by 1.1 to the power of 0, and then 1.1 to the power of 1, and then 1.1 to the power of 2, until you got 1.1 to the power of 9. In the denominator, you got 1.05 to the power of 1, and then 1.05 to the power of 2, and then 1.05 to the power of 3, until you get 1.05 to the power of 10. We would like to get a closed form representation of this formula. The good way to do it is to multiply the left hand side and the right hand side by a factor of 1.05 divided by 1.1. If we multiply by this factor, we can create a new formula such that the formula can cancel out most of the term with the original formula. As you can see here, after the reduction of the resultant formula highlighted in blue can cancel out many of the term with the formula that highlighted in yellow. Look at the equation here. The term in blue come from the blue formula, and term in yellow come from the yellow formula. You'll see that many terms cancel out. You see that the first term cancel out, second term cancel out, and the last term cancel out. After eliminating all the terms that cancel out, the remaining formula is really simple. We can find the present value easily by manipulating the formulas. To do that, we just need to multiply the left-hand side and the right-hand side by 1.1. You get the new formula. In the next step, we just need to factorize the PV out on the left-hand side and factorize the 100 out on the right-hand side. Finally, we just need to divide the left-hand side and the right-hand side by the coefficients of PV, which is 1.05 minus 1.1. You will get the closed form representation for the solution. Try to evaluate this expression with a calculator. You are going to get 1184.67. Let's get the formula in general. You will see that 1.1 is 1 plus g, 1.05 is 1 plus R, and 10 is the number of payment, and 100 is the initial payment, and 1.05 is 1 plus R, and then minus 1.1 is 1 plus G. You notice that this is just 1 plus R minus 1 plus G. When we simplify the 1 plus R minus 1 plus G, you will get R minus G. The next step is to replace the initial cash flow, $100 in the last question, with C, and then replace this term with R minus G, and just copy this 1 minus, and this term with 1 plus G, and this term as 1 plus R, 10 as number of year, which is 10 cash flow in total. That's the general formula for the growing annuity. That's it for today. Thank you.